Hi everyone. We are discussing the new chapter, which is chapter D, which is continuation of number system module. The first topic from that we have surds and indices. So first question: x raised to 9 is equal to 9 raised to 9 raised to 9. Then find the value of x. Now to solve this question, the first step that you should do is on that right side, get rid of that scary power. So 9 raised to 9, let that be equal to m. So now your question is x raised to 9 is equal to 9 raised to m, which is a bit little less scary. Now, because we were supposed to find out the value of x, that means we need to get rid of x raised to 9. So that means we need to take the ninth root. If we take the ninth root on left side, that also means we should take the ninth root on right side as well. So ninth root of 9 raised to m, and the formula that we'll be using is nth root of a raised to p. When we do that, the value x is equal to turns out to be 9 raised to m by 9. So nth root of a raised to p formula is a raised to p by n. Now what you will do after this is substitute the value of m, which is 9 raised to 9, and after this we'll use the division wala formula. Whenever the base is same, powers will be subtracted. So that gives us 9 raised to 9 minus 1, which is 9 raised to 8. So the value of x and the final answer of this question is x is equal to 9 raised to 9 raised to 8, which is first option. Second one, arrange the following numbers in the ascending order. So simply you are going to use the formula of nth root of a. When you do that, nth root of a is a raised to 1 by n. So square root of 2 will become 2 raised to 1 by 2. Cube root of 3 will become 3 raised to 1 by 3. And sixth root of 6 will become 6 raised to 1 by 6. Now, obviously, there is no way you can find out the fractional powers. So what you will do is convert them to proper powers. And to convert them to proper powers, what you will have to do is take the LCM. When you take the LCM, the answer for 236, the LCM is 6. So let's make every number raised to 6. Now after that, which rule we'll be applying? We'll be applying a raised to m, the whole raised to n, and the powers will be multiplied to each other. So we'll get a raised to mn. So 2 raised to 1 by 2 into 6 will be 2 raised to 3, 3 raised to 2, and 6 raised to 1 respectively. Now we can easily find out the values. 2 cube is 8, 3 square is 9, and 6 raised to 1 is 6. We were supposed to arrange them in the ascending order. 6 will be the first one, 8 will be the second one, and 9 will be the third one. So that means sixth root of 6 is the first number, followed by square root of 2, followed by cube root of 3. That is the ascending order. Third one, simplify the following expression. Now don't get scared with this. Just consider the first number and we'll use rationalization. So rationalization is multiplying both the numerator and denominator with the conjugate. So root 9 plus root 8 ka conjugate will be root 9 minus root 8. So when you do that in both numerator and denominator, in the denominator you will have a plus b and a minus b. So a plus b and a minus b, the answer will be a square minus b square, which will be 9 minus 8, which is 1. So that means only in the numerator you will be left with the conjugate, which is root 9 minus root 8. Similarly, when you apply that to the other terms, because the numbers are consecutive, all the terms will have the denominator part as 1 respectively. So that means their respective conjugate is only thing that will be left in the numerator. And now because we are supposed to add them, again what will happen, the alternate pluses and minuses will cancel out each other. So that will give you the answer as root 9 minus root 4, that is 3 minus 2, which is 1. Find the square root of 7 plus 2 root 12. So here we need to remember the formula of root a plus root b the whole square. So root a plus root b the whole square will be, that is a plus b the whole square, that is a plus 2 root ab plus b. And now that trigger 2 root ab is what you are supposed to understand. So 2 root 12 is your 2 root ab, yani ab is 12, yani product of two numbers is 12, and the sum of same two numbers, that is a plus b, is has to be 7. So we are looking at such two numbers whose sum is 7 and whose product is 12. So only one pair which satisfies this, which is 3 and 4. So a and b is 3 and 4 respectively. So root 3 plus root 4 the whole square, when you expand, you will get 7 plus 2 root 12. But if you remember, we were supposed to find out the square root of that. And when we find out the square root of that, we'll have to also take the square root on the left hand side. So on the left hand side, when you take the square root, square and square root will get cancelled and you will be left with root 3 plus root 4. Fifth one, if PQR is equal to 1, then the value of this expression. So the idea here is you will see that there is a pattern that is repeated, which is all the numerators are 1, all the denominators has a very specific thing, that is 1 plus some variable, an inverse of some other variable continuously, that is happening 1 by 1 for each of the variables of PQR respectively. And there is a plus in between. And whatever this pattern that is repeating, if such is the case, then they are called as cyclic expression. So remember, students, that whenever such is the case, that whichever may be the pattern, it may not be the same exactly, but as long as it is the same pattern repeating everywhere, it is always called as a cyclic expression. And the beauty of cyclic expressions is that their sum is always 1. So the value of this expression will not be dependent on the values of PQR. PQR can be anything, can be fractions, can be positive numbers, can be negative numbers, can be anything literally. But the sum of these expressions will always be 1 because they are cyclic expressions. Example, PQR sum product of three numbers is 1. The simplest possible assumption that all of them is 1. And when you substitute all of them as 1, you would get the answer as 1 because each of the term becomes 1 by 3. 1 by 3 added 3 times will give you 1. But you don't have to do this. This is just for the representation purpose. Main underlying idea is the cyclic expression concept and the trigger to remember that. Next one. Three numbers are equal to each other. We have to find the value of some expression. Similar kind of a thing we would have explored in ratio proportion. Let all of them is equal to k. Individually also they are equal to k. So the value of 3 in terms of k will be k raised to 1 by 2x. For 4 it will be k raised to 1 by 6y. And for 12 it will be k raised to minus 1 by 3z. Ironically, when you observe now, this is like pure observation. On the left side, when you multiply the first two numbers, 3 and 4, you get the third one, that is 12. Same thing should happen on the right side. So k raised to 1 by 2x into k raised to 1 by 6y will give you k raised to minus 1 by 3z. Laws of indices, base is same, and whenever there is multiplication in between, the powers are supposed to be added. Then we'll shift that k raised to minus 1 by 3z on the right side. It will become plus, and the entire thing is equal to 0. Cancel out kk from both the ends. Later on, what we will do, if you remember the value that we were supposed to find out, 1 upon 2x plus 1 upon 6y plus 1 upon 3z, we have just now figured out that value, entire thing is 0. And that means the final answer will be 0 plus 5. Answer is 5. Option 3. Seventh one, 4 raised to x plus 5 minus 4 raised to x plus 4 is equal to 3. Find the value of x. Two, three approaches are there. One is you substitute the value of x from the option, check which value satisfies, you get your answer. Second way, you actually simplify this expression and then find out the answer. Third one is a smart option that I'm going to discuss. When you observe the power x plus 5 and x plus 4, what you end up realizing is that they are two consecutive powers of 4. When you observe the powers x plus 5 and x plus 4, what you observe that they are the two consecutive powers of 4, back to back powers of 4, and their value difference is 3. When you think from that perspective, which consecutive powers of 4 has a value difference of 3? So it is 4 raised to 1, which is 4, and 4 raised to 0, which is 1, and 4 minus 1 will be 3. So that effectively tells me that in the place of x plus 5, it should have been 1, so that it becomes 4 raised to 1. And in the place of x plus 4, it should have been 0, so that 4 raised to 0 is 0. Sorry, 4 raised to 0 is 1, and 4 minus 1 is 3. So you solve for that. Either x plus 5 is equal to 1 or x plus 4 is equal to 0. Both the expressions, after solving, you will get the value of x as minus 4, which is answer option 5. So the two consecutive values of, sorry, powers of 4, and the difference of the value between them is 3. 4 raised to 1, 4 raised to 0. Answer option 5. So x is minus 4. So we are done with this. If you have any questions, let us know. Thank you so much.